Hi Amelie, so these were the two questions you sent me. I'll have a little go at them now. Let's see what we can do. Okay, so, oh yeah, with that first question, definitely in radians, must be in radians. If there's ever any differentiation or integration involved with trig, you're in radians. That's the way it's got to work. Okay, if I'm going to do this, I think I'm going to pick the substitution let u equal x plus 2. It looks like a nice one to use. And then I get du by dx is 1. In other words, du can just be traded straight away for dx, which is nice. So what am I going to have? Well, x is now going to be u minus 2. The 2 here, I'm going to throw it outside. Then I'm going to have u minus 2. This is going to become u to the half. And dx is swappable with du. Just remember to change the limits. That's the limit for x. And so this is going to be 4 and 2. This is the kind of question you know when you've done it right, because we know what the answer is. Okay, so before we integrate, I will need to quickly multiply out the brackets there. I'm going to get u to the 3 over 2 minus 2u to the half du. Everything's been changed to be in terms of u, which is nice. Now, increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. Well, that's times in by 2/3, which is times by 2 4/3, between 4 and 2. So what are we going to have here? Well, let's do it all over here and hopefully end up with the answer. We're going to have 2 times, open brackets. Right, when we plug in 4 square rooted is 2, 2 to the power of 5 is 32, times by 2 is 64 over 5. 4 square rooted is 2, cubed is 8, times by 4 is 32 over 3. Now we're plugging in 2, square root is root 2, then to the power of 5, that's going to be root 2 5 times, and I think that comes to 4 root 2, times by 2 is 8 root 2 over 5. I'll know if I've made a mistake in a second. Root 2 cubed is going to be 2 root 2, times by 4 is 8 root 2 over 3. Now, I mean, they've taken out a factor of 15 here, so it seems natural to write this as, well, if we change everything to 15ths, we're going to get 192. I mean, I really wouldn't want to do it like this, but we'll do it. Okay, 192 minus 160 over 15 minus, and then we're going to have 24 root 2. Just be careful with the sign errors here. Minus 40 root 2 all over 15. Personally, I would definitely take out the 15 now, so I can call that 2/15. And then what are we going to have on the top? 190 minus 160, that's 32. And I've already taken out the 15. And then we're going to have 24 root 2 minus 42 root 2. Well, that's minus 16 root 2. But minus 16 root 2 becomes plus 16 root 2. Take out a factor of 16. You're going to get 32 over 15. And then 2 plus root 2. Was that the answer? Yes! Done. Hopefully that wasn't too bad. Hopefully you can see why we're getting the root 2's there. It's because of root 2 cubed. Okay, and then it was 14 part C here, I think. I think that's what you said. 14 part C. Let me just quickly have a look at the thing. Oh, hang on. Can't remember exactly which bit. Yeah, part C, only part C. So, okay, right. Let's have a go at this then. Let's have a go. The line with equation x plus y equals k intersects C at 2 distinct points. Now, we've already shown that C is really this quadratic. Y equals 6 minus x minus 3 squared. That's C. And we've got this line x plus y equals k. And we know it intersects C at 2 distinct points. This sounds to me like one for the discriminant, yeah? Now, I'll show you what I mean. Firstly, if they do intersect, then k minus x, because that's y, I could rewrite that as k minus x. Well, I'm now going to plug that in as y equals 6 minus x minus 3 squared. Yeah, I'm going to multiply it out. So I get 6 minus, doing it carefully, x squared minus 6x plus 9, but I'm going to change all the signs on those ones. So I get k minus x is 6 minus x squared plus 6x minus 9. And therefore I get x squared if I add it onto this side. And then I'm going to get minus x minus 6x, which is minus 7x. And then I'm going to get 6 minus 9, which is minus 3, but I'm adding it onto this side. So plus k plus 3 equals 0. Now, you can't solve this, but you do know that this will have two distinct roots if the discriminant is greater than 0. And that's what you need to use here. And so we're going to have 49 minus 4 times 1 times k plus 3 is greater than 0. Yeah, and then we've done b squared minus 4ac is greater than 0. Smash him. And therefore, what are we going to get here? We're going to get 49 is greater than 4k plus 12. If we add all that to that side, that's what we get. So that's going to be 37 is greater than 4k, and so 37 over 4 is greater than k. So k must be less than 37 over 4. Now, are there any other values we need to worry about with k? Because it's often the case that you don't get all values here. Now, did you see here, explain briefly why C does not include all points on that curve? Yeah, this is something you answered in B part 2. And I presume that you're going to point out that x isn't defined for all values here, because sine fluctuates between 1 and minus 1. X is actually going to be trapped if that's between 1 and minus 1. If it was 1, x could be 5. If it was minus 1, x could be 1. In other words, minus 1 is less than or equal to x, which is less than or equal to 5. And so as x is trapped between those values, that's going to affect our range of values of k, because basically it's a quadratic, but it's only defined, and it's an upside down quadratic as well, but it's only defined from x is minus 1 up to x is 5. That's a nasty question, that is. Now, 5 minus 3 is 2, 2 squared is 4, 6 minus 4 is 2. So when x is 5, y is 2. If we can just get this roughly right. And when x is minus 1, you get minus 1 minus, right. Oh, was this 1 or minus 1? That should be positive 1, shouldn't it? I apologise for that, Amelie. So when sine t is minus 1, you get 3 minus 2, which is 1. So x is stuck between 1 and 5. Now, when x is 1, you're going to get minus 2 all squared there, which is 4, and 6 minus 4 is 2 again. In other words, you're only dealing with this part of the curve. Yeah, it's just like the, oh, and it's, yeah, and it's that way around because it's a negative quadratic. So what I'm going to do now is I'm going to need to consider when I've got x plus y equals k, when it's not going to hit these lines twice. Yeah, and that's actually a bit more difficult to do. Let me draw it a bit clearer down here, but I could understand people missing this last bit of this question. So we know our curve goes from 1 to 5, and that's y is 2. And now we want our x plus y, sorry, x plus y equal to k. We want that to hit this curve twice. Now we know, provided k is less than 37 over 4, it's going to hit twice up here. Yeah, that's with k is 37 over 4. But as long as we're hitting it twice down here, then we're good. Yeah, that's the thing. You've got to make sure you're hitting it twice down there. Now, that's where you really need to think about, okay, how can I make sure that this is hitting here twice? Well, if you think about it, when x is 5, yeah, y is 2. So as long as k is equal to 7, it's going to hit it twice down there. And as long as k is greater than or equal to 7, it will actually hit the quadratic twice. That's really subtle, though, that last bit. Really, really subtle. I'd be happy if you got 37 over 4. K is less than 37 over 4 in the exam. I really would. I think that would be done wrong by the vast, vast, vast majority of students, as in the vast, vast, vast majority of students who are getting everything else right in the exam will probably miss greater or equal to 7. And it's purely because they tried to highlight it for you by getting you to do that B part 2 bit, but that's the reason why the discriminant doesn't kick out all the answers. Now, write your answer in set notation. Well, just put some, curly braces around things. K such that 7 is less than or equal to K is less than 37 over 4. And those are those two questions, Amelie. Hope that makes a bit more sense. I wouldn't beat yourself up too much about missing that k is greater than or equal to 7. That is tough indeed.